Ladies and gentlemen, please welcome our next speaker, Michał Ostruszka, presenting the topic, Things I Wish I Knew Before I Started with Event Sourcing.
Okay, hello. By the way, the AI massacred my name, and that's what I was expecting, to be honest. So once again, my name is Michał Ostruszka. I'm from Poland. That's why probably it was the hardest task for the AI to go with. I work at Software Mill. We are a software house company doing crafting software for our clients. And today I'm gonna talk about some things and some facts and traps that I learned about event sourcing and things I wish I knew about that paradigm when I started with that. I barely see you, but the first question would be how many of you is theoretically familiar with event sourcing? Raise your hand, please. Okay, most of you. And how many of you have had a chance to use it on production? Okay, slightly less. Cool. So let's go for those who are not that familiar with. Let's go through some of the basic concepts of event sourcing. I asked my buddy, ChatGPT. I guess most of you these days have the same buddy. We have the same buddy, and I asked ChatGPT to answer in 2 sentences what is event sourcing, and it told me that event sourcing is a software architecture pattern where state changes are stored as a sequence of events rather than just the current state. So basically, in kind of typical application, typical CRUD-based application, you have your entities, your business entities, whatever it is, let's say user bank account. You have that entity stored in a database as a form of, let's say, one logical row in a database. And then whatever action comes in to modify the state of the account, you just update you just select the current state of account, you do an operation, and you issue an update on the database to persist the current state. The event sourcing kind of flips that idea and ditches that idea for saving the state of the application as a save of the business entity as a series of events, as a sequence of events. So every single action that you execute on the account, on the hypothetical account, you store as an event, you store as a fact that happened on that account as a kind of log, append only log. And that has kind of big consequences and big impact on the way you handle the application and the way you, the thing and the possibilities that you can do with your data. These event streams are a single source of truth for your applications. So there is no state like in a database that you keep in some extra place. You keep state and then you keep a sequence of logs, a sequence of events. The sequence of events is just a single source of truth for your application. But basically, coming from the text to the picture, how it works, in order to execute any action on the hypothetical account or any other business entity that you may have modeled as event sourcing one, you might need to execute a command. Because if you query the system, it doesn't change anything. By design, queries should not change the system of a state. It should be just a read-only operation. But if you want to change the state of an account, for example, I don't know, deposit money, withdraw money, you need to issue a command, which is an intent of changing the state of the account, like decreasing balance, increasing balance, depending on the operation. And when the command comes in, and you can think about the rectangle as this account, as a picture of this account entity. When the command comes in, what happens in the typical CRUD application would be that you would just load a single row from the database. You would just select account by ID and just have that account state to work on it, to update, to execute the operation on it. In event source applications, it's slightly different, or very different. You have this events journal, and you can see that when a command comes in, there's a series of events that are fetched from the database, from the event journal, and they are applied to the state, to an initially empty state. They are applied one by one in order to constitute, in order to build the current state. So if you apply all the events, like user deposited 10 euros, then withdrawn 5 euros, and then again deposited, I don't know, 20 euros, all these events in order are being applied to the initial state. And the final state after applying all these events is being built. And that cloud, the state built from events, cloud picture is here on purpose, because that cloud is kind of symbolizes the thing that the state is not persisted anywhere. It's a state that is built entirely for and exclusively for this command handling thingy. So after the command gets handled, the state gets decommissioned, gets removed. So if you have the state built, only then we can apply the command, because we have the current state, we have all the events applied. We can apply the command and issue a business logic on that. And after issuing the business logic, like checking, for example, if user can withdraw given amount of money, or if user can deposit given amount of money, depending on the business rules. After handling the command, you issue, you produce 1, 2 more events depending on your logic, and these events get saved in an event journal. And on the next command, all these events, all these 3 events from the top and plus these 2 events from the bottom are streamed again, replied, and then the next command gets handled. So this is the right side of the event sourcing one. It's not that complicated. I mean, it may look scary until you kind of shift your thinking to that paradigm. But after you issue a command, after you do an execution, do an operation on your account, you may want to do some query to view the state of the accounts, be it user interface, end user interface, be it a reporting for internal business needs, or any other kind of view projection, you name it. And for that, there is a second component of event sourcing. It's called read side, read model projections. It depends on the technology framework or even language. The name may be different. There's a read side, which kind of listens for the events that have been persisted to the event journal, and it builds specialized projections, specialized views for the data. You have a bunch of data. You have like event streams for every single user account, and you can build views that focus on particular aspects. On kind of you look at the data from the particular perspective. And there are also event handlers, because our applications don't live in a vacuum. Usually, when we decided and we produced an event that user is allowed to withdraw, I don't know, 10 euro from his account because he has enough balance, we usually want to communicate with other systems to let them know that that request was handled, that withdrawal command was handled, that the withdrawal event was produced, and these are the event handlers for. And the thing they do is usually doing some input-output thingy, communicating with other systems, calling synchronous methods, sending messages to message brokers and all that stuff. And the most important thing here to notice is that all the yellow part of the picture is one transaction, like saving the events to the journal is one transaction, but usually reading the events from the read side and reading the events for the event handlers is the other transaction, and may be executed in completely different service, completely different ecosystem, completely different database even. That's why there's the event sourcing and CQRS paradigms are usually linked with eventual consistency. And basically, that looks like the event sourcing idea looks like this. So the first thing is that I would like to talk about is that you may not need a framework, although it looks like complicated until, as I said, until you shift your thinking to that paradigm. But you may not really need a framework. That's again the same answer of my buddy, but just underlined the other thing, other quote in there. It's a reconstruction of past states by replying these events, and this is what we basically need to do in order to handle the command first. So if you code, if we like show it in the code, it looks like that. If you are into, this is by the way the Scala code. What we need to do first on handling command is to rebuild the state. Fetch all these events for the entity and rebuild the state. So we fetch the events in the line 2. We fetch them from the load event stream for given entity ID, because we know this is a user with a given, let's say, bank account ID. Then we have this initial state, which is initially is empty. It's like default state with an default settings and a balance of 0. And then we take all the events and iterate through them, applying all these events to the state. And we apply every single event to the state that was built from that is built from application of previous events. If you are not into this functional thingies or the fold left thingies, that may be more clear to you. It's just a for loop. We are just iterating and like changing the state and then returning the state at the end. So this is the part when we load all these events and reconstitute this cloud from the very first picture. This is the state at the end. This is the state that we are going to operate on. And handling command is basically rebuilding the state first. This is what we just did. Doing the business, and doing the business doesn't do any I/O, doesn't do any contact with external services or stuff like that. It just produces some events that we decided, okay, the user is allowed to withdraw 10 euros from his account. And at the end, we just persist these events. So we append these two events from the previous picture to the database. And that's basically it. That's the simplest implementation of this right side of the event sourcing. So you don't really need a framework for that. What about event storage? You may ask, because like we need to store the event somewhere. So the database, pretty much every single database can handle it happily. It just needs a way to append the events. And basically every single database, if you throw at it problem of just appending events, not modifying, not inserting, not updating stuff, just appending new events, will be happy to scale a lot and be happy to be performant in that kind of load. So we just need a way to append new events to the new rows to the database for each event. And we also need a way to listen to the events from the read part, from the read side, and from the event handler's point of view. It can be done via, I don't know, write headlog from the Postgres, via CDC, like the BZM if you want, or even via simple pulling. Every, I don't know, second or 2 or 5 seconds, you may just pull for the new events from the database, because you know the previous events have been stored and they are not modified. They are immutable. They are there, and once you read them, you are guaranteed that they are not going to be changed. So this is the kind of read part of the event sourcing. It may need a bit of a boilerplate to write that stuff, but it's not really much. So you basically don't need a framework for that. But for the storage itself, there's a excellent dedicated database which is called Event Store DB, which is written and founded by Greg Young, who is an author of the event sourcing concept, and he's building this Event Store DB. There's a free version of it. There's also a commercial version in the cloud that you can use, that you can subscribe to. But also relational database as Postgres. So you are not limited only to Event Store DB. We happily use the Postgres on the really high load event source systems. I know people using MySQL for that. I know people using Cassandra. We used Cassandra in one of the projects back then. People are using DynamoDB. There are tons of frameworks, integrations. For example, in a Scala world, we mainly use ACCA persistence for that, or PECCO persistence now. They have tons of the adapters for different database backends. So if you use the framework, you don't have to worry about that. But crafting one manually is not a big deal, really. You may ask, okay, it's about the events, so it may look like Kafka is a good fit for that. It's actually not. And I mean, it can be built on Kafka with a lot of gymnastics, a lot of plumbing on top of it. The main thing is that while Kafka can store the events for you, there is no way if you store the events in, for example, one topic for all the entities, there is no way you can cherry pick the events for each entity when you want to replay all the events for given entity to handle the command. You are forced to replay all the events from the entire topic and discard most of these. So that's one of the reasons why Kafka is not a big, not a good fit for that. We can talk about it later if you want. There's a lot of reasons why I wouldn't use it for that actual purpose. Time traveling. This is the big thing, and this is the stuff that I really enjoy and really value in event source systems. It gives me a kind of debugger on my production data, because we are humans. We make errors, we ship features, and we ship bugs together with the features, and shit happens. And it may happen that you have an aggregate or an entity that is event sourced, and you have series of events as on the picture, and at some point you find out that the user is raising a ticket to your customer support that he cannot log in, he cannot access the account, his account showing wrong amounts or stuff like that. And then what would you do in a standard CRUD application? You would go to a database, select the account by ID, select the user, and try to look at it. But you wouldn't really know what happened, because everything you had is just a state, like current snapshot of the state, the current version of the state. With event sourcing, you have entire history of the facts that happened on the account, the events that have been recorded for that account, starting from the very first deposit, through all the, configuration changes, all the option changes, through all the deposits, withdrawals ordered over time. And what you can do, like in a debugger, just go through every single event and try to find one that was applied incorrectly. Maybe that's a wrong event, maybe that's an event that has a wrong payload, maybe, for example, you have an event that has two, integer fields or two decimal fields for balances, and you just flip them around. And this is what's causing the issues there. With this time traveling thingy, you can go through all these events one by one and locate and find one that was wrong. But raw event stream, like if you go to the database, raw event stream is pretty much unreadable. It's a bunch of rows in a database. Sometimes it's in a kind of plain text. It may be in JSON, like EventStoreDB likes to work in JSON. In my projects, we usually work with protobufs, binary formats. I'll talk about it, the reasoning and the motivation for that a bit later. But the raw event stream is pretty much unusable. It's just a bunch of events, depending on how long your stream is. It's just a bunch of events, and applying them, like looking at them from just plain select query from the database is not a really good thing, because it doesn't tell you much. That's why pretty much every time, very first tool I built for my event source system is that kind of debugger thingy, just to kind of command line tooling or script or whatever it is, just to go through the journal, event journal, the event log, just to be able to navigate and go through all the events, to be able to replay events up until, 1 month from now, and discard all the rest, to see how was the state of the entity like 1 month ago. And that kind of tooling, that's one of the tools that I usually build. Over the course of the projects, there are different ones for building projections, like ad hoc projections, custom views on the data, analysis of the journals, and all that stuff. So building tooling for event source projections, for event source systems, is really valuable, and it's good to build the tooling in a way, like build and grow the tooling. It's not to treat it as a one-time throwaway code. Just build and curate that stuff for you, because it can be really helpful for troubleshooting issues. But now when we have the bug located, we know what happened. We know that there is something wrong within our business logic. We need to fix the bug somehow. And if we know that the event, for example, was flipped, the payload was flipped, the big decimals were flipped in the payload, it may be tempting to override the event. Like just go to the database, issue a query. For example, if it's a JSON, issue a query, update that field, like payload field, payload column in your Postgres, and just change the payload of this faulty event for this given user. But please don't do that. I did it twice, and I was scared as fuck every time I was doing that. Why? Because the events are the single source of truth, and if you stored an event, remember that there are these read sites and event handlers that have already processed your event. They may have built a report out of this event, of this faulty event, so the report may be wrong, but still it handled that event. Event handlers may have sent that to the message queue. Event handlers may have sent request some operation from another system synchronously with that faulty, based on that faulty event. And if you override that manually, there is no information sent down to the customers, down to the read side and down to the event handlers, that something changed. Because remember, when event is saved, it's guaranteed by by the conception of event sourcing that is immutable. It should not be changed. Once anything processed that event, it assumes that that event is done. That event should not be changed in any way. So you have no way to inform the customers, inform the clients, inform the read side, inform the event handlers about the change that you have just done manually in that. That may be not a big deal, but assume that there is a national investigation or trial or something, and there is auditing required for that. Event source systems are very often used. Event sourcing is very often used for systems that require heavy auditing, that require the base for auditing, that require single source of truth to be written as a sequence of events that is easily inspectable, that you can reason from the series of events, the sequence of events, and if that was the basis for your event source system, and if there is an investigation, audit, or whatever it is, and it happens that you are the developer that changed the event manually, you may have serious issues. If there's I don't know, governmental system or stuff like that, you may have serious issues really about it. What to do then if we know that, okay, there's this faulty event and a bunch of our customers are down and cannot execute anything because the app is down for them. Send compensating command and produce compensating event. It may look like tons of work because let's say we have, I don't know, million of customers and like 100 of them is just impacted by the issue. It would be easier to just issue a SQL query to override the event rather than producing new command, producing new event, handling this new event, and deploying all that stuff to work. But the really big advantage of that is that, again, you have this fact of a correction recorded in your event stream. So every time anyone wants to replay the stream, it sees, okay, this faulty event and then a bunch of other events maybe, and then somewhere in the stream, down the stream, there is a correcting event that corrects that faulty balances. And you have the record of that fact, and you have the information about that correction happened. Moreover, having the event being saved in an event stream forces the event handlers and the read sides to handle that event somehow. Because if they don't have a handler for that new event, they will fail, they will panic. They may want to discard it, they may want to ignore it, that they don't care about it, but they are forced to explicitly tell that. And that way, you may correct the reports in your projections, in your read side. You may send again the proper request to the other systems. You may send proper message once again to your message brokers, and everything is fine. Assuming the clients are okay with like applying with using the new version of the event. But it's up to them. It's not your fault. It's not your role to care about it then. This is about the bugs in write logic, how to fix the business logic that you write. But what if you have the bugs in projections? Let's say you have a complicated query to calculate some financial metrics out of your data, and there's all events are good in all the streams, but you have a bugs in projection. Some calculation was done wrong. It's even simpler because you take the projection, you throw away the projection, you deploy the new version. You deploy the new version of a code with a fixed logic, and you throw away the old projection and you rebuild the projection from scratch because you have all the events since the very beginning. It may take hours, it may take sometimes days. So you may want to throw away the old projections a bit later, but you have all the events, and what you do is just interpreting the events. You just interpret the events stream the new way with a correct logic in here. This is something that we've done several times when we discovered, usually in the very first phase of the projections building, when there were some tiny bugs, we've been just throwing away the projections, rebuilding them. Usually at the beginning there was not many events, so it was blazingly fast. So just replying the projection, having all the event, having all the source of truth in the form of event stream, it's really good. It's really good thing to have to rebuild, to build correct projections, to build correct view on your data. And speaking of correct views on the data, powering insights is yet another big feature to me of the event sourcing. This is the one that I value a lot. This is kind of a meta thing because I'm quoting Oscar, who is quoting Anita. But anyway, by the way, the Oscar Duduc, if you are from Poland, maybe you may know him. He's a kind of king of event sourcing in Poland. Basically, if you in Polish IT, if you talk about event sourcing, it's basically by default Oscar. But Anita said on one of the conferences that event sourcing is architecting for tomorrow's questions. And basically that's really true, and it's one of the best kind of short explanations of event sourcing to me, because you have all the information baked into the events. Like you saved all the data that were meaningful when you handled the command. You save them in an event, you have all the data in your database. You should not limit yourself to not to store given information. If you have doubt whether you should store given information in an event, you should. Storage is cheap, and that information may be priceless later during the business evolution. Business needs change over time. Now they may want two kind of reports that you can happily build, but in few months they may want the third type of report or few more types of report, looking at the database, looking at the data, for example, for your accounts, for user accounts from a very different angle. If only you have the data in your system, in your event stream, you are good to build that projections. You may need to, you may run it, and it may take days to rebuild the projections, but you have a way to do that. You have the data in order to build that projections. And that's really valuable, and that's one of the cases that we had not so long ago in a project, that we had a project running for 4 years now, 4 or 5 years now, and we had tons of events in there, and at some time, like a year ago or something, the business came to us and wanted one particular view of the data, like to analyze some stuff, to get some metrics, to get some insights on it. What we did, we just built the new projection. It was running through, I guess, 2 days in order to be complete, in order to catch up with the latest events. But hey, we had the data, we could build the projection. It was just a matter of time of running it. Having the CRUD way of storing the data, so having just a snapshot of a state, we couldn't do much really. We could only tell what's the current state of the application, and that's it. So yeah, build any projection you want, answer any of the business questions, if only you have the data in the events. And as I said before, the event streams are a really good base for audits, because the event stream, you can just like format the events in a kind of human readable way and show it to, like, hand it to auditors. This is what happened on the given account. We have the full history of that. Data consistency. Any guitar players may be in here? No? Oh shit. Okay. This is a kind of one of the guitar pedals, Strymon Volante, which does a kind of delay thing, like echo thing is, so like delaying the sound a bit. So I was thinking that's a good illustration for the data consistency, eventual consistency, and all that stuff. So basically that's the same picture as before, but with these two clock icons added to the event handlers at the read side. Because remember I mentioned that the yellow part is one transaction, so the events are being stored in one transaction, and the read side and the event handlers are usually eventually consistent. Usually because it's another process that can connect to your application, just pull the database every, I don't know, second to get new events to apply to read side or to apply event handlers to. It may be CDC, it may be write-ahead log, but still that's totally different transaction from the write side. This gives you awesome benefits of in form of ability of scaling that read side, because if you have so many read side, you can scale them horizontally as crazy, and also you can, and without impacting the write side, because it's totally separate transaction, totally separate database, and all that stuff. So all the benefits of CQRS apply here. But the eventual consistency may be kind of scary, and sometimes you may come to the point when the strong consistency is really needed. I mean, my hint and my experience is that usually if you ask business if they want to be strongly consistent, they'll say yes. But if you ask them what's going to happen if the data is going to be there in like 2 seconds, 5 seconds, not a big deal, it's fine. Then it turns out that you can happily live with the eventual consistency and make use of all its benefits. But if you really need a strong consistency, there is a possibility to do that. Especially if you handcraft the event sourced thing by hand and you do this all event saving by hand without any framework. You can have events journal and your read model that you want to be eventually consistent, put it in the same database, put it in the same same transaction, and once you write the event, you may also update the read model, and now you are strongly consistent. After the transaction saving events, you have the strongly consistent read model. That's one of the options. That obviously limits you to having the read model in the same database. So you cannot really use all the benefits of different storage system for different purposes. Like if you want this read model to be used for heavy analytics, you may want to have, I don't know, columnar database, document database. But if you have events journal in Postgres, you are forced to make a trade-off to have it in the same database to be able to put these two in the same transaction. But there is a kind of risk with that, and I saw that in one of the projects, that events have been saved consistently with a read model. First it was one read model, then it was then it were 2 read models, and then it ended up with 5 or 4 read models. And that causes a risks because first every single additional update to your event storage increases the latency, and you want your read side, you want your write sides to be really fast, because it's just appending on saving events, it's just appending to the log. It should be really fast to handle the commands from users. And introducing these updates to the read models may introduce consistency, may introduce another latency. And also the fact that every single logic in the read model, like interpreting the events, may be buggy. And then if any of these 3 read models fails, you are failing your event persistence transaction. You are actually invalidating the comment, rejecting the comment because of the fault. You don't want to do that. Your primary goal here is to handle the events from the user, handle the comments from the user, and produce the events. And what should be done on the read model should be independent from what happened in the events journal. There should be totally separate processes. So there is a way to do a strong consistency, but use it wisely and limit that to as few read models as you can, if that's only needed. And usually embrace eventual consistency and its benefits. As I said, usually most of the businesses can go with eventual consistency on board. It's all fine. There's an option to be strongly consistent. Shift your thinking to eventual consistency way. For example, there are ways to model, I don't know, user email uniqueness in eventual consistent way using event sourced aggregates. There are some talks and some articles in the internet about it. I'm not gonna talk about it because there's lack of time. And the next thing, performance of event source systems. Usually event source systems are the ones that are kind of critical, that need high speed, high performance, at least the right performance of an event, like high ingestion of user commands. And it may happen that you have a long stream of events. You have a user that is trading or making changes on his account that are so frequent, like several hundred trades, let's say, per day. So if you have that account modeled as a user account, your event stream may grow and grow. If you have 10 events, it's fine. If you have 100 events, it's still fine to load them in one go from the database, to reply them in the memory and apply the command to that. But if you start having thousands, millions of events for one user, and it's not, and it may happen that if user has an account for several years now and it's pretty active, it may have millions of events. There is a way to do that, to overcome that, but it's usually kind of an optimization thing. There's a way called snapshots that some people use for that. What you basically do with snapshot is you have this event stream, and every, let's say, 1,000 of events or every business condition that the account is in, you make a snapshot of the state, you save it in a site database, and next time the command comes in, you first look up the newest snapshot for the given account, load the snapshot state, and apply all the events that happened since this snapshot. So you don't start with an empty stream, as we started before at the beginning. You start with a snapshot and then apply only these few events that have been there. This technique dramatically increases the load time and decreases the load on the database, because you don't have to load millions of events. You just need to load, I don't know, 100, maybe a few hundred of events together with a snapshot. But be aware that this is an optimization pattern only. It's like fixing, like hotfixing the event source system, hotfixing your thing, because it is a sign that you may want to take a step back and see if there is no hidden concept of a business entity that can work well, can work way better in your domain than this one giant user account. For example, for user accounts, it may be that you may want daily user accounts. So for example, on every single day, there is a rollout of the user balances, and then you have short streams with, I don't know, hundreds of events for the given user for the given day, and you just roll out for the next day when the command comes in. Then you have multiple shorter streams, which are way faster to reply when the command happens, because, for example, you don't have to care about the previous events from the previous days, because you have the initial state of your entity to be the rollout from the previous day. So maybe modeling your domain slightly different. Maybe that snapshot need for the snapshot thingy kind of gives you a hint for the new model that you haven't yet discovered in your domain. It also introduces state to maintain, because for the snapshots we need to snapshot the state of the entity. So we kind of do this kind of crude thingy. We save the current state of the user account somewhere in a database, and we have to maintain it. Then over time we don't have a single source of truth in the form of an event streams, but we also have these snapshots to work with. With hot entities that are very often touched, and there's many operations that executed at them. Again, thinking about the domain and thinking about the boundaries of your entities may be beneficial. Maybe there's something you can do better. It's an issue because in the stateless apps that we used to build, it's the best way to build the applications that are scalable. In a stateless application, if you have several nodes, the command from the user can land on any node, and then any node should be able to wake up the user account entity, reply all the events, and execute the command. And you can imagine for hot entities, there may be tons of stuff, tons of operations on a database to do that if the entities are frequently used and there's a lot of commands for a given entity. So database becomes a bottleneck. And command handling slows down, because first you need to load all these events, and then you need, and only then you need to apply the commands to these events. And also the concurrent modifications. If you have a user account and two commands from the user suddenly land on two different nodes, how do you manage the concurrent access for that? Maybe optimistic locking, maybe versioning, but then introducing optimistic locking and versioning kind of amplifies the load on a database, because if there is a conflict, if there are two operations pretty close to each other, if the first operation succeeds and the second one fails, you need to refetch all the events again and again and again in order to find the correct version and find the right spot to save the event with save the new event with the correct version. So we are amplifying, even more amplifying the load on the database. What's the solution for that? What if you keep the entities in memory for some time? That's doable, but then if you have several nodes, there's a problem with that, how to synchronize them. So then how to guarantee the exclusive access to them to the entity, so that if you have account on two nodes, there's no such thing that you have account on two nodes. If the requests land on two nodes, they are directed to one single instance or a copy of entity that handles the commands for the user. There's the thing that is called single writer principle, and it does exactly that. It moves the complexity from the database. It kind of offloads the database to the application level. It introduces some complexity on the application level itself, but offloads the load on a database. And while a database cannot be scaled that easily as applications, like by adding more nodes of the application, it may have significant, it may bring significant improvements. So basically, what it does is, for example, in our Scala world, we use usually Akka cluster with cluster sharding, with Akka persistence as an event source implementation. So what it does, the nodes of the application form a cluster, and it's guaranteed with the cluster sharding is guaranteed that within the cluster there is only one instance of a given account, user account. It may be brought into the memory and kept into the memory, serving commands very fast and guaranteeing the exclusive access to the entity. But again, that offloads the load from the database, but introduces some complexity on the application level. Evolution and maintenance of the event source systems. They usually live long. If we invest into the event source systems, they are usually kind of critical, and they live long. They are not like one-time throwaway applications. So think about your event versioning strategy since the very beginning. Think how you are going to version the events, how you're going to add new events, how you're going to decommission fields that are no longer needed in a given event, and so on and so forth. Choose a payload format that supports the evolution. This is why I'm, for example, choosing the protobufs, because in protobufs there are clear rules what's the compatibility of the payload of your event, rather than in JSON, which is kind of structured, but there is no clear rules on how you can evolve the JSON schema. Choose carefully what goes into an event. You may want to save as many information as possible in your event, but not too many. I saw a project where people were saving entire state that was built in this previous cloud. They were saving it as a part of an event for basically no reason. I don't know why it was done, but it was kind of to the extreme. And on every single change, if you want to do the change on a business logic, think whether you want to have it as a new field or new version in your event, or new optional field in your event, or maybe it deserves a completely new event. Maybe the event structure is the same, but it's totally different business process, and then it's worth having totally new event with its own name, with its own meaning, rather than just having event like version 2 or event with kind of yet another optional field. And keep event handlers for the past events. Even if you don't use the feature, even if you decommission the feature, keep the events, because if only the event has been written to the database, there is no way back. You need to handle it forever then, because if someone wants to reply the stream, if there is no handler, it will panic. There's a great book of Greg Young. It's not finished, but still, versioning in an event source systems. I highly recommend to read it, even if it's not done. There's a lot of strategies, a lot of issues with that may have happened that you may benefit from even if you're not using event source systems, how to version payloads, how to migrate payloads from the database and all that stuff. Scaling read side, the quick one. On the events journal, if we assume that we have this polling, for example, and we have multiple consumers of this polling the database, the more consumers we have, the more load we put on the database from the read side thingy. And that kind of limits the number of consumers or read side models that you may want to have. Again, a problem, pretty much every single problem in IT can be solved by adding yet another abstraction layer. So it's in here, except of the issue of too many abstraction layers. So in here, there's a message queue between that. So if you put, for example, Kafka, which is one consumer that reads from the event journal, then on the other end of the topic, we can scale as crazy. We can scale to as many read models as we want. And private versus public events. It may be tempting to produce with the event handlers to notify all the customers, all the consumers of our, all clients of our systems with all the events that we have. I wouldn't do that. I would usually keep all the events that we have private and only publish the events that we have, that we know that we want to publish, that are business, that are meaningful from the business point of view, that we have a strong contract with. It enables us to, doesn't work. It enables us to evolve the internals, evolve the event, maybe sometimes just completely ditch event sourcing while still maintaining this outer layer of API compatibility. So don't tie your customers to your private events. You only publish what you want, what your other services want from you to publish, and obey some contracts. This gives you the ability to change the internals, change the events, migrate the events, maybe ditch the event sourcing out. So the summary, event sourcing is not really a new thing. It's like many years old. It can be implemented without specialized framework. Embrace eventual consistency. It may sound scary, but that's a way to scale your systems like crazy if you want to scale. Have the versioning strategy from start, because if you don't think about it, you will have hard time when then changing your requirements, your business requirements, changing your flows, changing your events payloads. Make use heavily of the read side power. It has incredible power. It can look at the data from very different perspectives that you may even not think of at the moment. And challenge yourself with event sourcing and have fun. Thank you.
For your talk. Very, like a lot of information. So the problem is we're a little bit out of time. There is a panel starting. If somebody wants to go, just go there. Otherwise, let's go and take a little bit of your time out of the lunch pause.
I'll be there. I'll be there somewhere, maybe in the Ask Me Anything corner after that.
But
talk.
If you want, we can go over, let's say, top 3 questions.
Cool.
First one, you did present the snapshotting, but are there other things? How does one handle increasing replay times when the system gets older with time, years, for example?
That's the thing with snapshotting is a kind of cure for long streams. So if you, let's say, you didn't model your domain, let's say, properly. With event sourcing, we should target for many streams, but streams that are short-lived. So, for example, this thing with an account, instead of building one entity for user account that is like spanning long years, you may build one that has, I don't know, span of a month, given user, and let's say it's May of 2024, and then next entity of the same user ID and June 2024, rolling out this current balances, like starting the new entity for the new month with balances or the state from the previous month. For that, when the command comes in June from the user, you only need to reply the June part of it. All your views, all your read sides are still correct because they are built from the very beginning of the event stream. So all the balances are correct on the read sides. You have all the data, you have all the events, so you still can build all the new projections from this data.
Thank you. How often have you had a feeling you are over-engineering the things with using the event sourcing?
Twice. Twice and once we ditched event sourcing after some time, after the system was running for half a year on production. We ditched it because it became complicated. We went with domain modeling totally wrong. We did all this errors with the long streams and all of that stuff. We ditched that because there was no, there was over the course of the project, it was around a year, I guess, and there was no single use of any of the benefits from event sourcing, basically. So we decided to ditch it. But yeah, it's really tempting if you have a hammer, like everything looks like a nail. So it may be, you should question that if you really need auditing, if you really need this time traveling, if you cannot go without it. That's not an easy pattern, actually, to be honest.
Okay, and the follow-up question, again, I said we only do top 3. You said you had to fix events manually 2 times. Why?
Why did you fix 2 events?
Yeah, you said that normally you have the complementing order.
Compensating action,
yes.
yeah.
But you had to implement the fix on the database manually 2 times.
Yeah, that was before the okay, one was the project that was built with an event sourcing. I don't know why really, but it was internal project. There was no need for auditing. There was no need for projections and all that stuff. So it was easier just to go to do that. And the other time was when we just didn't think that we could do that. And there was not many consumers on the other hand, like event handlers that we could screw. So it was timed.
Okay, so no risk.
Since now I don't do that. It's like doing that on production is like you can sweat a lot doing that. Like it's neurosurgery.
Creating parallel timelines.
Yeah, something like that. Like you cannot change the past. So.
Gotcha. Alrighty. Again, you can find our amazing speaker outside of this hall. Currently is the lunchtime, so try to catch him and ask more questions in details.